Landscape, right? Yes, it's landscape. Okay. Thank you. All right. So once again, these are our different polar graphs, as we may notice for that. So we got the circle, cardioids. So it can be a horizontal cardioid going right or left, or up and down cardioids. We also have some limacons, lemniscate, odd or even rose curves, and Archimedes spirals. These are just some of them, but definitely there are some more, okay? Once again in here, we are considering some different tests for symmetry as such. Once again, if you are given your polar coordinate r theta, and it so happened that you sign change, okay, or negate the r, or what we call the radius, then it's basically a what? A 180-degree rotation from r theta to negative r theta, right? So once again, if you negate the r, then that's going to be a 180-degree rotation. However, if that is what the angle, right, then the theta, the angle that you negate, then there's going to be what we call a polar axis symmetry. Where's the polar axis? Where this is the pole, that is the polar axis. That basically is your theta equal to 0 radian, right? So that's your polar axis, okay, in that case. Now, if that is the theta that you negate, so for example in here, if that is your theta, then that means this is your negative theta, then that will be what we call symmetry along the polar axis. In short, if you flip this one along the x-axis or in polar coordinate graph, theta equal to 0 radians, then that will be your polar axis symmetry. Last one. This is the what we call symmetry along the theta equals pi over 2. In rectangular coordinate, that's basically the y-axis. So if there's a y-axis symmetry, then that means you negate the r and you negate the theta as well. Okay, so as you may notice in here, if this is your r theta, your negative r negative theta will be the following in here, right? So as you may see, it was reflected along the y-axis, or what we call the theta equals pi over 2 line. Okay. Also, as you may notice, as I have put in here as a diagram, if you actually combine, right, if you talk about composition of functions, if you actually combine symmetry with respect to the pole, like for example in here, this r theta given, if you rotate it 180 degrees, okay, and after that, you what? Get its symmetry along the polar axis, you would notice that those two combined will be the symmetry along the pi over 2. Get what I mean, guys? So in short, if I am in here, okay, I rotate, what did I say? I rotate, bless you, 180 degrees, right? Okay. And then after that, I have my symmetry, right? Flip it along the polar axis, or the x equals 0 line, or the x-axis line. Then I'm going to have the y-axis symmetry. Well, let's see now what we have as follows. Let's try first graphing number 20, right? Let's graph number 20 in here and see what kind of symmetry we're going to have from that, okay? Let's read this one. Logan, what's number 20?
R equals 5 minus 5 sine theta.
Thank you, right? So in here, we got the following. 5 minus 5 sine theta. Okay, so as we may notice in there, that is of this form, right? That is of the form this. R is equal to A plus B sine or cosine of theta, right? And as you may notice in there, what's our A and B? They're both what? 5, right? So that means, what is that case? Is it the green, the blue, or the red? Where the A's and B's are what? What's the ratio between A and B in there? 1, right? Since your A and B is equal to 1, so that means we're talking about it being a cardioid. So we're going to see what kind of cardioid it is. Also, as you may notice in here, it will also tell you what orientation it will be, okay? So here it is. If it's a sine, okay, if it's a plus b or a minus b sine theta, then we are assuming it to be either going up or going down, okay, depending on the sign. However, if it's cosine theta, again, a plus or minus b cosine theta, then we are seeing the orientation either leftwards or rightwards, depending on the sign. Okay, so that is 5 minus 5 sine theta. Sine theta. So what are we considering? Up, down, or left, right? Okay, so it's a cardioid with that sign, right? So if it's sine, then it's what we call downward orientation, right? Well, let's verify if we are correct with that, right? What's that again? 5 minus 5 sine theta, and simply graph it in here, okay? So again, in graphing, make sure it's in radians, okay? Make sure you're dealing with polar graphs or polar coordinates, and put it in here. So let me just go ahead and X this out, and seeing how the graph looks like, okay? Once again, simply graph it. R is equal to 5 minus 5 sine theta. How do we get theta in here? You just type it in the Greek letter, theta, theta. Got it? Okay, so we can see already in here how the graph looks like. First of all, what kind of orientation are we looking in here? It's going down, right? So it's going down in there. What kind of graph is it? As we may notice, it's a cardioid, right? So you notice it's a cardioid in there because your A and B are the same. That means the ratio is equal to 1. Okay. Also notice, where is that 5? Okay, so as you may notice in here, the 5 is somewhere here, okay? And that is also 5. Okay. If you double that, that will be how much? 10. Right? So that again, this is our 5 minus 5 sine theta is equal to r. So this 5 equivalent to those two, and 5 plus 5, if you double that, that will be 10. Right? So cardioid going down. One more thing. Let's consider now what kind of, once again, what is this? A cardioid, right? Now, what kind of symmetry does this one have? Does it have a symmetry with respect to the pole? Does it have a symmetry along the polar axis? Or does it have a symmetry at theta equals pi over 2? Theta equals pi over 2. Where is that line theta equals pi over 2? So this is your line, this one in here. That is your line what? Theta is equal to pi over 2. Good. As you may notice, it actually is symmetric along that line. Okay. Now let's verify if that is correct, right? Let's talk about 1 r theta here. So the easiest r theta that we can consider is this, right? So what is this r theta? This is what is this point in here? This is 5, 0. Oh, 0. Okay, that 5, 0, then that means the other one would be what? Negative 5, and this is what? Negative 0, right? That's a good question, right? So here it is, right? So it's negative 0 is basically just 0 in here is basically coterminal of negative 0, which turned out to be how much in this? It's basically pi. Get it? Okay, so with that being said, negative 5, negative 0, we can just write it as what? Negative 5 pi. Okay, and with that being said, then we can say that they are what we call symmetric. Questions? Questions, guys, with that? That is our symmetry along theta is equal to pi over 2. Or in rectangular coordinate, it's called the y-axis symmetry as well. Yes, go ahead, Amaya.
What is the WRT?
Oh yeah, WRT. Very good question in here, okay? Yeah, WRT is basically just my abbreviation, guys, talking about, this is what we, with respect to, right? There you go. The pose. Got it? Okay, so again, if we say, if I say WRT, it's basically my shortcut term for with respect to. All right? Yes, Jocelyn, what's up?
What does that say? The one loop?
Limason, all right? So that's a good question as well. That's called a limason, right? So that's a C with a tail, right? Those who did, I would say, French or something, that's like one of those C versions of the French language, right? And again, that is called what we call a limason. And there are two as well, two types of limason. What we call a one loop limason, like that one. And the other one is a inner loop limason as well. So we're gonna consider some types of those limasons and see how they look like. Yes?
So the only difference between a cardioid and a one loop limason is that slight differences in the way they curve in.
Mm-hmm. Yep. As you may notice in here there's basically like a smooth dent, but in here there's like a sharp dent over there. Okay. So you can also consider that one as like a little bit of a heart shape. Okay. And the other one is more of like a kidney bean shape or something, right? Is it a kidney bean or something? Yeah. Okay, so let us consider now some other equations, right? Let's try this one, number 26. We got number 26 as follows. And let's see what we got from number 26. Cecilia, let's see what we have for number 26.
R equals 10 plus 9 cosine theta.
Thank you, right? So R equals 10 plus 9 cosine theta. So first of all, let's consider our A and B, right? Good. And what do we do in here? Let's get the ratio between them, right? So what's this gonna be? A over B is equal to what? 10 ninths. Okay. And what can you say about 10 ninths? Is it more than 1? Yes. Okay. Is it less than 2? Yes, right? So with that being said, then we can consider this one to be, what kind of loop is this? One loop limason. So we can consider in here this, we are expecting it to be one loop limason. Okay. What is the orientation of this one loop limason? Look, that is cosine and that is positive. So we are considering it to be what? What kind of orientation are we talking about? Up, down, or left, right?
Left, right.
Right. Okay. Good. So that is left, right. But since this is positive, so we are considering it to be right orientation. Okay. But let's see. How does it look like? Okay. Just to verify if we actually get a one loop limason for this. Okay. So let's put it in here as follows. R equals, what's our equation again? 10 plus 9 cosine, all right? Parenthesis, if you want to put parenthesis, and type in the word theta, okay? And let's see how it looks like, okay? Got it? So let's see. Where is your okay, noticing in here, what is that? And what is this? Both are at 10, right? And as you may notice, that is your A. So you notice in here, that is your A value, and this is our A value as well. Also, as we may notice, what's this? 10 plus 9, that's what? 19. Now, what do we notice about this? Among this to there. How much is that one, guys? 19. Right? However, if you notice here, on this part, how much is that? Oops. 1, right? Radius 1. Now, in terms of symmetry, so once again, what kind of limason is this? It's a one-loop limason. Okay, not inner loop, but one-loop limason. Okay, now, last thing to do is to see what kind of symmetry does this one have. So if the other one a while ago was a symmetry along the, theta equals pi over 2 axis, right? Where do you think is the symmetry for this?
Polar axis.
Polar axis symmetry, right? So where's that polar axis? Polar axis is this in here. Let's color it black, right? So this one is your polar axis. Right? And as you may notice, any point in here will be equivalent to the other point on the other side. Get it, guys? Okay, so for example, that one will be having that one in here, right? This point in here will be having this other point in here. And as you may notice, there's the symmetry along the polar axis. Questions with what we did in here? So once again, that is our test of symmetry and how to consider this in here. Let's now, any questions regarding this? One loop limason. Next one, what do we have in here? Number 32. So these are some other polar graphs. Let's consider number 32. It says what in here? R squared is equal to what? 36 cosine 2 theta. So let me just go ahead and X this out. Oops. Here, so we have the following. R squared is equal to 36 cosine 2, theta. Okay, here's the deal. In our calculators, we cannot have R squared. In the syntax, it would always say, we only need R. So, if you just want R, how do you get rid of that square?
Square root.
Square root, both sides. Okay, very good. That is correct. So this is what we're going to do first. To put it in decimals, you just need to have R instead. So in order to just have R, we can just write it out as like that. Okay, so either plus or minus square root of 36 cosine 2 theta. Again, I put plus or minus because either of those two will be fine. Now let's see how it looks like on our end. Okay, ready guys for that one? So go here and type it in. Again, R squared is not allowed for our decimals, but R is. So basically, just get the square root of both sides. So R equals square root, okay, 36. What did we say? Cosine of what? 2, and then theta, right? So just type in Theta, that's the Greek letter theta, and that will be our graph for such. Okay? Now, what kind of graph is this one, guys, right? Did it tell us what kind of graph this one should be? So check on your summary and see which among those correspond to this kind of graph. Okay? Okay. 36 cosine 2 theta. Let's go back to our summary and see how it looks like and see which among those correspond to that. Lemniscate. Okay, lemniscate. Now, regarding this lemniscate, what kind of symmetry does it have? Okay, so we know already the term for this one is a lemniscate. Lemniscate. Well, regarding this lemniscate, what symmetries does it have?
Symmetry with the pole.
Symmetry with the pole, that is correct, right? So as you may notice in here, whatever point you got in here, okay, whatever point you got in here, for example, if this is your r theta, if you rotate this 180 degrees on the other end, okay, there we go, right? Then you would notice that this is what? Again, this is what? 180 degree rotation. And this point is also corresponding to that, right? This is your negative r theta. So yes, correct? There we go. There's a what? Symmetry. Again, I would abbreviate this WRT with respect to, right? The pole. Oops, just pole, just one. Okay. Are there any other symmetries for this other than the symmetry with respect to the pole?
Symmetry at polar axis?
Symmetry at the polar axis? Well, let's see, okay? So, if I choose any point in here, all right? Let's say this one, right? Let's call this our R2, theta 2, right? Then that means if it has a symmetry with respect to the pole or polar axis, here's our polar axis, where will it lead to? In here. Okay, so that is your what? This is your R2 negative theta 2, right? So yes, there's a symmetry along the polar axis in rectangular form. That's your x-axis, by the way. Are those the only two that we got? Yes, Kendall, that's correct as well. As you may notice, it has all kinds of symmetry. Good thing with this one, right? Look at that. This is your theta equals pi over 2 axis, right? Or the y-axis. So any point in here, if you see, it has symmetry on the other end as well. Okay, so let's call this one, for example, this one, right? What's that? If this is your R3, theta 3, a third polar point, okay? If you put that one on the y-axis, then that will be this, somewhere here as well, right? Okay? Then that will be your what? Negative R3, negative theta 3 as well, right? So there's the symmetry along the theta equals pi over 2 axis. Or in the rectangular form, that's the y-axis symmetry. Okay? Questions? Questions, guys? So this is a good thing with this lemniscate. Well, at least this type of lemniscate, right? It has all three kinds of symmetry. Polar axis symmetry, with respect to poles or pole, and y-axis, or what we call theta equals pi over 2 axis symmetry. Questions? Questions regarding that? Okay, one last in here. One last. We got number 38. So again, this is a lemniscate. Last one in here, 38. What do we have? 5 sine 3 theta. Let's see how it looks like. 5 sine 3 theta. Let's put it in here and see how it looks like, right? R is equal to 5 sine, parenthesis, 3 theta. Okay, let's look at this one. Okay, what kind of polar graph is this one, guys? Okay, look at our summary and see what kind of graph we have in here, okay? See this one. It's basically a what? A rose curve. A rose curve, yeah, a rose curve with how many petals? Odd or even? Odd petals, right? In this case, since that is an odd number, so that means that is 3, then that means this is a what? A rose curve, right? Okay, annotate. This is a rose curve. And whatever n you got in here, alright, n is equal to 3, that's odd. That is the number of petals we got for this rose curve, right? 3 petal rose curve. Okay, analyzing this one first. By the way, there's also what we call even number of rose petals, but we'll see later, right? But for now, let's analyze first what kind of symmetry does it have. Does it have a symmetry with respect to the pole? Not, right? Because this one doesn't reflect 180 degrees, so no. Does it have a symmetry along the polar axis? None, right? Last one, does it have a symmetry along the line theta equals pi over 2 or y-axis? Yes, it does, right? So if we look in here, consider this as your theta is equal to pi over 2, or basically your y-axis for rectangular coordinate. As you may notice, it's symmetric. Okay, so there's a symmetry in there. So yes, there's a symmetry in here along what? Along the y-axis, or theta is equal to pi over 2. Again, since we are considering these are polar graphs, we don't name it as polar as a y-axis. Instead, naming it as theta is equal to pi over 2. Are we good? What we did? Okay. As a summary, these are our graphs, but there are other different graphs that you will encounter, okay? And you would see that one on our homework, but these are the common graphs, okay? Circle, definitely, cardioids, inner loop, limason, lemniscate, which we did already. We have an odd rose curve. We also have an Archimedes spiral. And as you may notice, in an Archimedes spiral, it doesn't have any kind of symmetry at all, right? No polar symmetry, no polar axis symmetry, no theta equals pi over 2 symmetry, and no pole with respect to the pole symmetry as well. Okay. Last one, rose curve, even. Let's call it like that. Okay. Rose curve even. How does it look like? So let me give. Give me an even number. 4. Let's try 4 in here. Let's see what we got. Okay. So that is your n is equal to 4 for this rose curve, which means if it's even, what do we do to determine the number of petals? Okay. If n is even, how many petals are there? You double, right? Okay. If n is even, you have how many petals? 2n petals all in all. Got it, guys? So once again, if your n equals 4, then that means 8 petals all in all, okay? So for example, if n is equal to 10, how many petals are we expecting it to have? 20 petals, right? So n equals 10 will have 20 petals all in all. Well, let's verify, okay? So let's just make this one. 10. Wow. Well, you go ahead and count, guys, right? But, we can verify that will be 20 petals all in all. 10 up, 10 down. Questions? Right? Thank you, Liz. And